Hi, my name is Dongbo Wang. I'm an engineer from the PowerShell team, and today I'm going to talk about some perf improvement work in PowerShell. Well, it's more of the current perf status and also the ongoing perf work we're doing in PowerShell right now. So first, I want to start with the current performance status. So with a huge improvement in the performance in .NET Core, PowerShell gets most of this perf boost at a steady stage by free, like for free. As you can see here, like this is an example that we're running this base64 PS1, which is a script written by Steve to implement a base64 algorithm that does a round trip conversion from a long string to base64 and convert it back. So we're running this in PowerShell 6.2. It's about 30% faster than running in Windows PowerShell 5.1. And you can see the numbers here. That's a very significant improvement in the steady state perf. But when it comes to the PowerShell startup time, it's not that happy anymore. Like we're not that happy. As you can see in the table, with the PowerShell, with Windows PowerShell 5.1, the start time is about 250 milliseconds. We use it as a baseline for a simple command call like echo1 and starting PowerShell. And in PowerShell Core 6.1 with .NET Core 2.0, we got 2 times slower here. And in the 6.2 time frame, we put some work in the startup time performance, and we make it a bit faster, like 25% faster than 6.1, but still, like with also with .NET Core 2.1, the tier compilation was enabled, and with all of them combined together, we got like 25% improvement compared to PowerShell Core 6.1, but still it's like 50% slower than Windows PowerShell. So the reason for that is the difference between engine and cross-gene. So in Windows PowerShell, we're using engine, which can produce the binary assembly for your IL assembly that can reduce the jet compilation almost to 0 at start time. So this is a jetting time like collected by using the perf view, and we can see that the jet time for the Windows PowerShell 5.1 startup time is almost to 0, like 9.4 milliseconds. But exactly the same scenario, PowerShell no profile echo 1, it takes about 120 milliseconds in the foreground jetting. And this foreground jetting is where the user gonna see the difference. So the background jetting, well, user won't see that. It happened in the background it happened in the background on another CPU core. And tier compilation background is also one formal background jetting. So the user won't see that. But the foreground jetting is where the application will freeze for the jetting to finish. So this 120 milliseconds will show up actually in here, in this 367 milliseconds. So this is unfortunate, but engine produce a binary that is more restricted, has more assumption, it's based on the local machine. But cross-gene has a more loose assumption. So it's expecting that the cross-gene assembly is able to work on multiple runtime versions. And that's why it's not able to handle some of the dynamic language related code properly, or if we are writing any generic, like using any generic types over a value type, then cross-gene will not be able to handle that as well. So all of them will be kept as IL and be jetted when the program starts. So speaking of the cross-gene, there's something I want to bring up is that in .NET Core 3.0 Preview 6, the cross-gene is now built in into the .NET Core SDK. So you can just simply using this publish ready to run property like this to cross-chain your assemblies to generate this mixed IL and binary code mixed assemblies. And there's another functionality enabled in the SDK, which is assembly linking. It's using this publish change property to do. And what it does is that if you specify the target runtime for your application and having this to be set to true, the SDK is able to remove, like, analyze your IL to find out all the assemblies that is not, excuse me, to find out all the framework assemblies that is not actually needed by your application and be able to remove them for your application. So it can help to reduce your application size. So then it comes to the performance and profiling. The tools are actually working pretty well with .NET Core on Windows. Like WinDBG works pretty well with .NET Core dumps. And if you're using cross-chain assemblies, like if you're using the official release of PowerShell and want to debug that, then you can actually use the non-cross-chain symbols and just force loading the cross-chain assemblies in the WinDBG, and everything's gonna work. And when we are working on the startup performance in 6.2 timeframe, we actually use this Windows Performance Recorder and Windows Performance Analyzer a lot to analyze the reference set at the start time. It helps a lot. It helps us to identify all the files that PowerShell touches when starting up, and give us some hint to try to reduce those files that PowerShell touch during the startup code path. And Perf view is very important and very handy. We use it to see the memory allocation issues, to see the GC statistics, the jetting issues, and the CPU stats. And if you are using cross-chain assemblies, Perf view actually can auto-generate the PDBs for your cross-chain assemblies. All you have to do is just copy the cross-chain exe to the application base folder. So for example, in PowerShell, if you want to debug the one official release of PowerShell, then all we have to do is find the corresponding cross-chain.exe and copy that into the $PS home, and then Perf view is able to generate the PDBs for our assemblies directly. And but when it comes to non-Windows platforms, profiling tools are quite limited. And today, we mainly do our Perf profiling on Windows and do the do the code changes corresponding to the profiling traces on Windows, and just hope that the same changes can have effectively, similar performance improvements on Linux and Mac OS. So our current Perf improvement work, it's still ongoing. It's not something like the team committed to. It's just we figure out that this is something we need to do, and we want to spend less time, not much time, but on things that actually have a good result. So we have some guidelines here. The first one is that it should be well guided by the profiling traces. We should not do some micro optimization, but instead we should just look at the trace and see the places that actually need attention, and then we will see if it's a low hanging fruits. If the simple changes or refactoring can treat for good results. If that's the case, we will do it. So in the current time, all we want to do for the Perf improvement work is to reduce the regression risk and just do simple changes, but result that result in good results. What's next? It won't be we won't be only doing the low hanging fruits work for PowerShell on the Perf area. What we want to do is actually first add some performance tests to track the Perf improvement and regression in the long term. So today in the PowerShell repository, we don't have any perf test. We have one test to track all the files, all the assemblies getting loaded during the PowerShell startup. That's all. Compared to the startup performance, I think the steady state performance is even harder problem, because the startup performance is very noticeable to the user and to us as well. Like, we are using PowerShell every day. When we start PowerShell, we can notice that it's becoming slower. However, the steady state performance, it's very easy to be, it's very easy to not pay attention to any regressions in the steady state performance. So what we want to do first is to add more performance tests, and let's look at the PR. We want to add more performance tests to track the PowerShell steady state performance in different categories. For example, individual commandlets, like those work closely with PS object. Those are the ones easily to get affected by any changes in the PowerShell related to the ETS, PS object, or etc. stuff. And scenarios that exercise particular components of the engine, such as parameter binder, especially when we're talking about parameter binding for the pipeline objects, which is a big problem for pipeline performance, and compiler, binders, and interpreters. It's not committed by the team, but we in the team we actually we're actually getting started with a culture, like spend 20% of time every week to do something that you think is important but not urgent in the short term. So this is one of the items we want to do during the 20% of the time. And let's go back to the slides. So the next thing we want to do is that to go through all the perf related issues opening PowerShell repository. There are actually dozens of perf related issues already open in PowerShell repo, maybe even more. So what we want to do is that we go through all of them. We get better understanding by doing some profiling and see if there are any low-hanging fruits that we can fix quickly. If there are any, we will just do it. If not, then by analyzing the profiling traces, we try to find out those areas that requires more fundamental changes. And then we track those findings for future. Like, once we have those list of items we need to do, like we know that we need to do to get better performance, the next thing is that the team can make a commitment to fix them one by one. So then I want to get to the examples. So let me show you. The work has been started, like mainly by me and Ilya. See, here are the PRs so far for the low-hanging fruits performance improvement work. There's one example I want to show. Like this is a PR submitted by Ilya. It's looking at the scenario of the module loading. So it basically load a lot of modules on a fresh PowerShell instance, so that it can trigger the module analysis, module cache analysis, the code. So when Ilya is looking at this performance trace, like this is actually from the GC. Let me show you this. It's actually from something called the GC heap alloc free ignore free stacks. What it means that it's actually collecting all the objects that has been allocated during the tracing time, even though many of those objects will get freed or reclaimed eventually, but it does not care about that. It only care about all the objects getting allocated during this time. So when looking at this trace, Ilya noticed that, okay, there's a culture info object, which is like it got allocated for 5 megabytes, and it's suspicious. So he looked into it and found out that it's actually because in our code, get assemblies. Well, this code is actually being exercised by by PowerShell when doing this type resolution. When doing type resolution, or give PowerShell a type, it first need to find all the loaded assemblies, and then searching from loaded assemblies to find the type. So this get assembly is actually using that code path. So he's find that, okay, actually in this code path, in this message, we're calling this a.getName. So what this method does is simple. Like it's trying to get all the assemblies based on this type name, and if the assembly we get, if the assembly like if this type fully namespace fully qualified type name is given, then it will go through a different code path. If it's not, then we will try to get all the loaded assemblies loaded assemblies from the default loader, and filter out those assemblies that are created for PowerShell class. And this guy is actually PowerShell class. The dynamic class assembly name is PowerShell class assembly. It's a dynamic assembly generated for the PowerShell class definition. So what we want to do is actually get all the loaded assemblies from the app domain, from the current default loader, but please filter out those PowerShell class related assemblies because we don't care about those. Those are resolved in a different manner. The way we were doing that previously is by looking at the current assembly's get name, so which gonna return the short name of the assembly the short name of the assembly name, and compare that with this const, which is PowerShell class assembly. But it turns out this get name method, it will do the allocation of the culture info inside it over and over again. Every time you call it, it's gonna do that. So the way to fix it is quite simple. Like it's a one-line change. Instead of doing this short assembly name comparison, we actually using the full name of the assembly and try to compare with to say if it start with this prefix. And this assembly.full name, it's actually owning the construction of this full name is only doing once, and then it's cached. So this full name property access does not incur any performance issue after the first time. So by changing the only one line, he's able to, like he said in the descriptions PR, that by changing this one line, he's able to eliminate this 5 megabytes allocation of the culture info. So this is one example of our guidelines we put in here. So it should be well guided by the profiling trees. It should be low harm for now. It should cause very low regression risk, and simple changes can be treated for good results. And next, I want to give another example, which is a little bit more complex. This one. Well, this is something I did to I don't know if you all know about it, but for each object is way slower compared to a filter. Like example here, compare this to. Oh, sorry. So when you're doing for each object, like simple operations, is 1 + 1, and compare with same pipeline, but instead of for each object, I'm using a filter with a process block in it. You can see the difference in time. This is after this perf change. We still got 4 to 6 times slower. So this PR is mainly started by we see that currently when using a filter in the pipeline, it's about 10 times faster than for each object. So why is that? We try to get some ideas about what is going wrong. So I did some perf analysis. Let me show you this. I won't start from the beginning. So in order to find out what's happening, I collected the trace by using this for each. Let me show you which command I'm running to collect this trace. This is the command I'm running. Basically, no profile and run a command, a lot of numbers and type into the for each 1 plus 1, and then finally assign the value to none. So it's pretty simple. And then the first thing I'll look at is this heap alloc ignore free stack. In our current perf work, we pay a lot of attention to the GC time actually, because like let me show you this first. So if you look at the GC status, you look at this this tracing, you can see that we actually spent 1.8 seconds in the GC. So when this GC is running, all the program is actually freeze. So that means we're waiting for the GC for like 1.8 seconds. So we look at the allocated object. This is a process I'm interested in. Okay, the first one is very interesting. The config scope. Config scope is an enum. However, it's getting allocated in the magic heap, in the GC heap, for like sorry, hope you can see this. It's being allocated in the GC heap for like 129 megabytes. So that's a big indicator that something goes wrong. The second one, it's a tuple, and it got allocated for like 57 megabytes. So I started from this two. Let's look at the first one, config scope, and we can see that it's actually being associated with the tuple. So it's very possible it's related to the second one, which is like 57 megabytes allocation. So look at this one, and we see it's actually getting from this utility, get policy setting from GPO. And then what we can do is look at the call stacks and find out what might be the call path leading to this message invocation. But eventually, I find this line of code. This line of code. So this is before the change. We're actually using a cache that holding all the policies we retrieved from registry for the group, for the GPO, the group policy stuff. And this cache is a concurrent dictionary. The key is a tuple. It's actually a combination of config scope enum and a string. The config scope is just a simply, if you look at it here, you'll see that it's simply all users or current users, this two, like one of these two members. And the string is what policy you are looking for. So basically, we have a cache here, and the key is 1, in what scope we want to look for. 2, the policy you are looking for, and the value for the key is just the policy we retrieved from the registry. So it looks normal. Okay, I'm using a tuple, but the tuple is a generic type. It should be able to handle this value type correctly without triggering too much issue. But further investigation revealed that no, that's not the case. Because we're using it in the current dictionary, like a dictionary, no matter it's a current dictionary or a dictionary, the key will be used to do the equality comparison as well as getting hash code. Let's look at what does the tuple 2. Oh, sorry. Go back here. In the new tab. Oh, sorry, all page. Okay. Let's first look at this equality comparison of the tuple 2. This is a tuple type. It's tuple with 2 items. And if you look at this equality comparison, it actually depends on this equality compare object. See here, even though this tuple is generic, it knows about this type 1 and type 2, which in our case, the type 1 is the enum type, the type 2 is a string type. However, when it comes to the equality comparison, you're going to use this equality comparator of an object. So, which means when we're doing comparison using this comparator, everything will be casted into an object. So it actually involves a lot of boxing, converting this enum value into an object, and over and over again during all the queries, in our code. Let me show you this. So we have this cache. And the cache is being queried a lot during our code base. In this code path. Basically, this get policy setting for GPU is trying to get some settings to say if I need to log a script block execution. So every script block execution will go through this code path. That means a lot of queries to this cache. And in order to do the query, we have to create the tuple. First, we have to create tuple, and tuple is very short-living. It's only the purpose is for querying the cache, and this costs a lot of allocation of the tuple. Second, once we use the tuple as a key, when doing the equality comparison within this concurrent dictionary, and when getting the hash code, let me show you the hash code here. Getting hash code is still the tuple type, and to get hash code again, it's using equality compare with an object as a type argument. So come back to our code. When we're doing this query using this tuple against this concurrent dictionary, equality comparison and hash code has to be executed. And both operations will involve boxing this scope, this enum value into an object. So that means creating this creating an object for this enum in the magic heap again and again for every query. And here too, in order to do the query, you have to create a tuple again and again whenever we get into this method. So once we find out the root cause, it seems like it's a simple change. Yes, it is. It's a simple change. If you look at the change history, there are only a few lines of change. So first, we need to change the cache into something different without depending on this tuple. So that means we cannot use a combined key here. Instead, we use a two-level cache. The first level is just okay, what scope you are looking for, and then I'm gonna return you another concurrent dictionary, and then you can use your policy name to query for the actual policy value. It looks like one more allocation, like one more level of complexity, because previously you got only one concurrent dictionary, now you got nested concurrent dictionary. However, it's actually reduced a lot of memory allocation. Especially in this case, like the config scope only have two members, so which means we only need two more concurrent dictionary allocated for each of the members. And during this search, let me show you this search. The search is also changed that we don't use the tuple anymore. We just use the scope to query for the first level of the cache to get back another a sub cache. And then we use a policy name to query for subcache to get the actual policy. So no allocation for tuple and no boxing operation over this enum value. So after this change, can say that here after change, you can see that we got no allocation for this config scope and no allocation for the tuple. That saves us like 200 megabytes of the GC time. It's if you look at the this again. This is a trace we get after the change. If you look at the GC status again, it's the same command we're running. Like now we only have spent 1.1 seconds in the GC for this long pipeline running, compared to previously. We spent 1.8 seconds. That's 700 milliseconds less, and that's 40% less time executing this command. And these two allocations are the most interesting ones in this investigation, but there are many others. Like, for example, this boolean. While we are creating boolean in the magic heap, there must be something wrong. Like this display class, it's 28 megabytes, and to be honest, also this one, this class, it's, if you look at this class, it's very, the name is special. So it's either a class auto-generated for a delegate closure, or it's a class auto-generated for iterator. So yes, I actually looked into these two cases as well. The first one, this one, is actually an iterator. It's a Yellow return used in this method, get matching parameter set data. I tried to see if it's possible to reduce it, but unfortunately, no, because of the parameter binding issue. That's a more fundamental issue. Because of parameter binding involved in this this execution, this method getting called a lot of times, and that resulting in a lot of allocations of this auto-generated class. For this one is something we actually can do stuff to reduce the allocation of it. Let's take a look at where it's getting used. The reason we are seeing this special class is because this is a class generated for the delegate closure, and it's using here. And this code path is a very hot code path. It's I won't say like every script block gonna hit this, but many script block execution will hit this code path. So what it does is that before I start to actually run a script block, I need to check if I can run anything in the current pipeline or not. Previously the way to do that is, okay, I'm gonna pass in this method call as a delegate into this method, and this method is let's see, before the change, this method will take an action. It will check if we can actually run in the current pipeline. If we can, then we just call the action. Otherwise, we just return, sorry, we cannot run in the current pipeline thread. So it looks to me this method does not need to take an action. It can just return a boolean to indicate whether I can run in the current pipeline or not. And that's an easy change. So I made the change to, oh, sorry. So I made the change to just check if it's possible to run in a current pipeline thread and return the Boolean result. And after this change, I don't need to pass in this method invocation as a delegate anymore. I can just like calling this method based on the return value, decide whether I can call it now, or I have to marshal this script block into the correct run space and run it. So with this simple change, we can see that, again, this class allocation was 28 megabytes, and after the change, it's gone. It's gone from the tracing. And same thing for the Boolean. The Boolean is actually it's sort of silly, to be honest. Let me show you the Boolean one. Look at the first one. In the parameter binder, we are running some trace message, and this a parameter was bound is a bool, but the write line only takes the object argument. So when we were previously just passing this bool to this object parameter, they're getting boxed, and that's why we get that's why we get like 28 megabytes of the boolean getting allocated in the magic heap. And the fix was pretty simple. It just calling to string and pass that to this object parameter. But during the code review, we find out this is actually a more general issue. There are many other places calling the same tracer.writeLine, and the proposal from Ilya was that we just have some overloads for every special primitive types, so that we don't need to change other code. We don't change in the code base in a lot of places in the code base. And he actually already created this PR to do this change. So what he's proposing is that we just add in more overloads to handle every special primitive type, so that rest of the code base can stay the same. So yeah, those are two examples. Just want to show them that we did spend a lot of time in the tracing, trying to find out the root problem. For example, here, for this for each optimization, the changes in this PR, it's just a simple changes, and which can result in good results. However, we do discover something that more fundamental. It's like after the change, we can see that it's still like running the same thing. It's still like 6 times slower. Once 250 milliseconds, and when using the filter, it's about 40 milliseconds. It's still about 46 times slower than using the filter function in this case. And the reason for that is first, for each object require parameter binding for the pipeline input. The parameter binding is a very big problem here. Like we discussed just now, that the reason we got this guy getting allocated for 43 megabytes is because the parameter binding. It's this method getting called in the parameter binding a lot of times, and many other objects allocated here are also related to the parameter binding. For example, this PS bound parameter dictionary is definitely related to parameter binding, and I believe this PS object is also related to the parameter binding stuff. So really what we need to do here is to avoid unnecessary parameter binding for pipeline objects by using some like DLR, dynamic language runtime features like the binder. So that the first time we do the actual binding, and the second time the something passed through the pipeline, we don't need to go through all the logic to figure out how to bind anymore. We just do the same binding. That's something more fundamental and requires more times and probably gonna cause some regressions. So we will not do it now, but we are tracking this work item in our backlog for triage. And the second one, the for each object calls into this invoke using command over and over again for every pipeline input. And this method needs to do necessary setups, cleanup, and after invoking the script block. So for each object has to repeat that task over and over again for every piped in object. However, for the filter, you only need to do the setup cleanup once, because it's basically just running the process block within the filter. It's still the same command. It's still same function. For the second reason, probably nothing we can do here. It's just because the different ways the filters and the for each object works. However, it's good to understand why we're having the problem here. Why we're having a big difference here. And third one is the for each object runs this in a current scope. It's something you probably want to know, is that for each object, where objects there, when you are specifying script block for it. It's actually running a script block in the caller scope, in the current scope. It will not create a local scope for the script block. And this has one implication. It means that when PowerShell is doing the compilation of the script block, because you are calling it, you're evaluating, running it in the parent scope, it will not do the optimization it can do when you are running it in the local scope. For example, if you are using variables heavily in your script block, then those variables will not be optimized to use the local tuples. It will just do a scope chain lookup always, and some other optimizations similarly. So when you are using for each, because you are running the script block in the parent scope, the compilation of the script block is unoptimized, and this will result in some perf lost. And it's something we cannot do when comparing with a filter, because when you're running a filter, it's always running in this local scope. So what I want to point out is that we are doing this analysis using this profiling traces. When we're doing the analysis, we really try to find all the problems that's causing this this perf issue. However, when addressing them currently in the current time frame, we only address those low-hanging fruits that can be easily done and result in good results. But at the same time, we do track the fundamental changes that are required to get better, more meaningful improvements. But those work will need the team to commit on and triaging and actually put resources on it, because it's going to take much longer time. And you can see currently we got these PRs opened and merged to do things that I talked about, like simple changes and result in better performance. And we're planning to keep on doing that. And yeah, that's basically it. That's basically my talk. Any questions?
Okay, can you hear me, Dongbo?
Yes, I can.
Okay, perfect. Let's see. Does anyone have any questions so far? I'm looking at Matthias over here. He's also very much involved. No questions? Well, a question from me then.
Sure.
With a for each object,
Yeah.
Wouldn't it be an option that if the bindings are not required, to just default to a filter object in the background instead of using for each, or would it be too hard to detect if it's?
It's something I considered, but I did not put too much thought into it yet. If you probably know that when you are piping something into out none, if you are doing something like this, let me show you. If you're doing GCM out none, PowerShell internally actually turned this into GCM pipe into $now. This is a performance this is an optimization. Like, you don't actually need this pipeline anymore. It's just I know what you're trying to do. I just do it for you in a more performant way. I was thinking about maybe for each object can also internally silently turn this script block into a filter, but it's like just by thinking about it, it won't be something trivial to do, and it probably can cause a problem, because if you turn into the filter, that means you're gonna run in the local scope, which might contradict to what you expect from for each object. Considering that, I'm more inclined to investigate to improve the parameter binding for the pipeline object in general, so that much more, many more other commanders can benefit from the same improvements. Basically, what I mean is that, okay, when getting the first pipeline object, I do need to go through all the parameter binding logic to find out which property I need to set this value to. However, after I'm doing this the first time, it's very possible that all the subsequent pipeline object will be binding to the same property. So in that case, probably I can save all the discovery again, like in subsequent discovery logic, like discovery code and the logics. Just use the same property I get from the first time and just do the value set. So that's the idea we're using the DLR binder, like dynamic language runtime binder. We're actually using a lot in our code already. It's based on the same idea that the first time, yes, you need to do the binding to resolve it, to find out how to exactly run the code. And the second time, it's very possible you're going to use the same binding result. So I just cache it and reuse that without calling to the same code to do the expensive work. If we're able to do that for the pipeline object parameter binding, I think the for each object can be improved a lot more. I think at least like 2 times faster, even after, like, let me show you the number now. Before this work, before this allocation, avoid extra allocation work, before that, we're looking at, we're looking at 500 milliseconds for running something like this. And after this allocation work, we're running the same commands, and it's 2 times faster, 250 50 milliseconds. I think if we are able to do the parameter binding more smarter using the DLR binders, we probably can get another 150 milliseconds less. So that will bring us to 100 milliseconds compared to the 40 milliseconds, which is not that bad anymore, based on all those difference in the actual implementation.
Okay, thank you.
Yeah, no problem.
Is there anything you would like to tell the people at DuPSUG about PowerShell 7, what you're excited about, or what they should try out as a closing remark?
PowerShell 7, we are still closing on the items we want to ship in the things we want to ship in the PowerShell 7, and I think the main focus will still be on the coverage, like how to make sure that we can reach 90% coverage for the Windows existing Windows PowerShell modules in PowerShell 7. And besides that, the team does decide to have a few customer delighters put into the language. For example, the pipeline training operator that Rob is working on, the NN or. Basically, it's like in the bash that you're running one command, and if it fails, then if you are using or, then the second command will start to run. If the first one succeed and you are using NN, then the second one will be like if the first one fail and you are using NN, then the second one will be skipped, something like that. He has published the RFC, and Rob, I think his implementation is almost there. And also, we want to have this ternary operators put in PowerShell. It's a shortcut for if else. Has been asking for quite a long time, but the team just decided to maybe do this for the for the PowerShell 7. And yeah, besides that, I think there's another feature about giving the user a notification when there's a new update of the PowerShell core, a new release of the PowerShell core. Basically, when you start up PowerShell, it's able to query to see if there's a new release, and if there is one, gonna show up the message when you're starting up the PowerShell. That one, I'm not really sure we're gonna put in the PowerShell 7 or not, because we're still having this debate whether it's worth the perf impact to the startup time. Yeah, and I think that's the things I know for sure that we're gonna put in, but there are many other works that are still like trying to finalize them during the planning phase.
Okay, thank you very much. everyone, we're about to have our break. Can I get an applause for Dongbo?
Thank you. Thank you.
Thank you very much, Dongbo.
Yep. Thanks. Bye-bye.
Bye.